Alright, so we discussed standard deviation, okay? And so now I want to explore that concept a little more. We've talked about how if it's a small standard deviation, the data is close together and doesn't vary as much. So vary means like spread apart. Variance, spread apart. The spread of the data. And if a standard deviation is big, excuse me, then one of two things can happen. The first thing is that the data is spread far apart, or there's an outlier, maybe two, that is skewing the data. And so that's why it's so large. All right, for you to fully understand what standard deviation is, what it means, and all that, it's going to take me a couple of lessons. I just need you to kind of go through the process of how to find standard deviation right now. And then we're going to learn about these things called z-scores and the bell curve. And then we're going to put it all together and just kind of like wrap it up in a nice tight package. If you want to print the notes and do it with me, you're welcome to. All right, so there's several distribution shapes. The main one, there's three main ones, okay, that we're going to focus on. Excuse me. If you're like me, you like work full time, you're going to school full time. I'm also going to school full time. I have kids, so it's like midnight, and I want to teach you this stuff. And so I know you're probably learning this, either late at night or on the weekends, crazy early in the morning, right? But we just have to stay focused and our eye on the goal. Passing math, learning it, and graduating. That's our goal. We can do this. Okay. So a lot of times on my videos, like, I'm gonna have no makeup on, I'm not gonna be in my teacher clothes. I'm like here for you. Alright, distribution shapes. Okay, so the main one that we're gonna do is kind of okay. This one is called the normal curve. Alright, it's also called the bell curve. %90 of like things that occur in the world fall in this. Socioeconomic status falls in this. Test scores, nearly every single test ever given falls in this. I mean, the examples I'm thinking are like way advanced. But yeah, bell curve. Where it's at. It's a great book called The Bell Curve. Gigantic. Okay. So with the bell curve, everything's pretty much right here. The mean, median, and mode are centered right there. And in the data, we will come to know the bell curve as that guy. Okay? And if you made like a bar chart of the data, that is like right here. Then there's two more. Oh. Oh no. Okay. Two more. There's left skewed and right skewed. Alright. Left skewed is also called negative. Negatively skewed. Right skewed is also called positively skewed. Hope you can read that. It's positively. Okay, I'm not super focused on this piece of it or that piece of it. I need you to focus on how left skewed, the tail is to the left. Right skewed, the tail The small part is to the right? So the hump, where the hump, okay, is like where the greatest data occurs, most data, okay, is the opposite of what it's called, right? And this could be drawn as a bar graph or a histogram. Looks right. All right, or you can just draw it with a curve. All right, so right now, we'll get back to these two kinds, but just kind of know that negatively and left skewed are the same, positively and right skewed are the same. All right, and we're going to focus on the normal curve, normal distribution, bell-shaped curve. We'll learn later. It also works for the Z distribution because of Z-score. Right, and here's what's important. On the normal curve, you have what's called the empirical rule. I don't care that you know it's called the empirical rule. My kids are sleeping, but if I move, they're going to wake up. If I talk softer, they'll just move around a little. All right, I know you feel it. I know. You understand my pain. Okay. All right, so the mean is right here. Remember, X bar means mean. Okay. Then 1 standard deviation, that's what this means the mean, take that number, and add 1 standard deviation or subtract 1 standard deviation. And that is 68% of the data falls in 1 standard deviation. That's more than half. Right? Then that means take the mean and subtract 2 standard deviations, or add 2 standard deviations. That's 95% of the data. Okay, if you take the mean and subtract 3 standard deviations or add 3 standard deviations, okay, that's 99.7% of the data. Right, so what I want you to focus on is 68, 95, 99.7. That's what I care about. 68, 95, 99.7. We'll do this a zillion times. Like, you should just learn it because we do it so much. And until you learn it, write on a little piece of paper and just reference it. No big deal. If I forget it, I just Google it. Okay, and I teach this all the time, and I use it for my research. So, I'm a little thrown off. Okay, guys, it's Halloween night. I muted the TV, and it keeps coming on, like the noise. Okay, anyway, I'm not making it up. Like, you can hear little talking, but I muted the TV. So who knows? Little fluke. All right, we're just practicing. All right here in the center is the mean, X bar. Remember, mean is also called mu. Meow. I guess it could also be a drunk cat. Moo, cow. Okay, right. Then we're going to do -1 standard deviation, -2 standard deviation, -3 standard deviation. Right, this guy, okay, just quick reminder, that's sigma, that O with a line, is sigma standard deviation, the like the S in the Greek alphabet. Okay. Then we have +1 standard deviation, +2 standard deviations, plus 3 standard deviations. Now we could, and most of the time you're going to see this just illustrated with a curve. Okay, so one standard deviation, okay, is 68% of the data, super important. 2 standard deviations is 95% of the data. Within 3 standard deviations, so the chunk of it is 99.7. All right. Now let's do some math with it. Okay, the national average for math SATs in 2011 was 514. Okay, so this is X bar average. Suppose the distribution is approximately bell-shaped, standard deviation, right? So that's sigma, the O with the line, is 40. All right, so what I do is, I'm not here for perfection. I'm here for progress. All right, so I draw my curve, and in the middle, I write my mean. 3, 2, 3. All right, and so now I need to take 514, add 40, add 40, add 40. So I get 634. Oh, that's this one. 594. Sorry, this is 554. Right, then I'm going to take 514 minus 40, minus 40, minus 40. I get 474, 434, 394. Okay, I added one standard deviation or subtracted it. I did it again. I did it again. Okay, so one standard deviation is this guy, 68. That's 8. 2 standard deviations is 95. 3 standard deviations is 99.7. Right now, so I draw this every time I do a problem like this. You get super fast at it. All right, what boundaries do you expect 68%? So that would be 474 to 554 is this answer. What percentage of the scores would be above 594? So that's right here. And we need that data. All right, so 95%, this is at the second standard deviation. Second standard deviation is 95%. So what I'm going to do is the blue, this chunk is 95%. So 100 minus 95 is 5. All right, so 5% is for this piece over here and this piece over here. I only need, we want above 594. I only need that. So I'm going to do 5% divided by 2, and I get 2.5%. So the top 2.5% is above 594. All right, I'm going to see you in the next video.